Okay, let's get started, shall we? We are now top of the hour, and I think a lot of us are already here. There might be some others joining afterwards, but I think we can already start with the introductions. So welcome everybody to our webinar over aerial drone data, and of course, how to capture actionable insights through this new technology, newish technology that has already really created a lot of praise in the renewable industry, which is indeed drone data. So if you have any questions, there is a question box where you can leave your questions and we will try to answer them all afterwards in a Q&A, or we will then send you the answers afterwards through private mail. And of course, this recording will be shared later on through mail to all of the registrants. So if you have any friends or colleagues who didn't manage to make it this time, don't worry, they will be able to watch this afterwards. So I am here joined today by my colleague Marketa, who is the hardware expert here at Sitemark. We have Joni, from the founder of Duracell, who has been working with us for quite a long time. And of course, we have Hugo from Mr. Drone, who is the commercial guy and also a drone pilot, so we can get some on-field expertise as well during this. And of course, I am going to be a bit of your host and coffee talk leader, Eric. I am the account manager and a customer success manager here at Sitemark. So on the agenda today, what can you expect? Well, of course, we're going to talk about the importance of doing this thermal analysis. Then we're going to go a bit more to really on-site problems, so different failures that you might have while doing this data acquisition. We're going to talk about challenges that we might see on whilst getting the data and how to mitigate these challenges. And of course, the importance of flight preparation. I think we can all agree that there's nothing better than having an almost fully well-prepared flight. Is already half the work is done. So to start with the importance of thermal inspections, I think this is a moment where Joni, a partner from Israel, from Duracell, can really take the leads and show us how he, for example, uses the Sitemark platform with the data that his pilots are getting on site. And I think, Joni, you have been working with us for 3 years, if I'm correct?
Yeah, correct. Thanks, Eric, and welcome to everyone who joined this webinar. Yeah, I think in the past, when I was an O&M manager for PV sites, we used to do the thermal inspections with handheld cameras. And on the way, when sites were smaller, that could be fine. But when the sites are getting bigger and bigger and bigger, to cover the full amount of the modules would be almost impossible to do it with a handheld camera. So when I started my own business and I met with Sitemark, it was, I think, 3 years ago, I think in the Solar. And then I found out that there is a platform like that. And using drones, you can collect the data of 100% of the modules at utility scale sites or small commercial sites, and then make accurate analysis. And to get this kind of result, what you see here on my screen is a scan that we did for one of our clients. And you can actually see that every anomaly found is marked and is classified according to a type and according to its cause. So, and then the client himself can get like a full inspection, health check for his PV site. It's becoming some kind of an industry standard that these thermal inspections have been happening upon commissioning of sites, just new ones, and then on a yearly basis, or maybe even longer, 2 yearly basis. But then a client gets a full picture of his site health condition, and you can show him the statistics and how much losses he can suffer from that. Yeah, it's uploading, but you can show him the losses, and you can show him how much energy he's losing as a result of these anomalies. And this has all been possible because the data collection is being done with drones. At the beginning, when we started working together, it was a little bit challenging to understand all the parameters and the settings that the drone pilots needed to do in order to collect the data accordingly. And I think that with your support, Sitemark support, and training the pilots, and also using the latest hardware, we can get to this kind of result. And what you see here on my screen is an example of how the data was collected on this specific scan. Each and every dot here is either a thermal image or an RGB image, which was taken by the drone. And you can see consistency, and you can see that we cover the full site. And with that, actually, Sitemark can work and make its own, let's say, magic for the analysis. And then we can provide a quality result to our client. And I think this is what we're going to talk about in this webinar, about how to achieve this kind of quality data collection with the drones. And yeah, we have here experts like Marketa and Hugo. And yeah, so we'll go over this.
Yeah, I think it's perfect that you actually finished with this kind of example, because I'm going to now bring up another picture where you can see indeed this problem, right? And you can see that the most important thing about doing a proper thermal scan is having the right amount of photos that can cover enough amounts of the panels, and panels in different kinds of photos. So you can see here that there's actually photos missing. And I think, Marketa, you are, of course, our hardware expert, and you work with us in the operations team, and you must get this quite a lot, right? That there's missing photos. So why don't you tell us a bit about your experience when you see this happening on an operational level?
Thanks, Eric. Welcome, everyone. It's a really great start to show this picture, because we can see that the missing images here we have marked in the red square, just to indicate the potential and the actual issue. And we know that every pilot is basically relying on the hardware, on the software, what application he's using, or what camera, what drone. All of this, it's very important factor. And also, no matter how you prepare at the beginning, how good you can be prepared, how well you can do the preparation in the flight program as a mapping flight, you set up the overlap, you set up the right GSD, and then you take off. But sometimes, what if the data are not as you expect it to be? And this can be, of course, an issue, because missing data like this can reduce the side and the front overlap. And reducing the front and side overlap can result in modules being missed. And that's, of course, something that neither the pilot, neither us and customer wants. So there are, of course, lots of factors that plays in. And what we can see, the issue that can be, it's, for instance, the speed of the SD card. So that's something that we always advise to check, but also the speed of the drone. And that is something that can be, of course, adjusted. So as soon as the pilot is spotting this issue, it's actually easy fix. It can be very easily fixed afterwards. And also one of the other is the GPS signal, because it can happen that the geotech doesn't work properly on the images. But also, actually, for me, looking at the left picture, there is a really great example seeing that on the right side and left side, the overlap is super consistent. This is really something great that we expect as a data to come in. But as in the middle, something went wrong. We can see that it always starts at the beginning of the flight. And there are, of course, missing images, meaning lower overlap. And that we can also say that it is really something that we see over past years that can be related to outdated hardware. And that is something that definitely has significantly improved over past years, basically by having not only dual cameras, which we know that already brings really good consistency as well, by having RGB and thermal at the same time, but also having DJI releasing the new sensors, for instance, the H20T or the new Mavic Enterprise Advanced. And I think that, Hugo, you can mention, talking about the right picture, that absolutely having, like in your equipment, probably such a equipment, such a new hardware, it's definitely helping your pilots to achieve good quality data.
Absolutely, Marketa, you said it all. Basically, flying the latest drone with the latest software makes almost 99% of achievements. But don't forget, we are living in a world where almost everything is automated. So being focused while you're flying about the consistency of the data acquisition is still something to remind while you are on the field, because when you go back home and then you just figure out that some photos are missing, of course, from a business point of view, that's a bad information. And also from a personal point of view, this means that you almost done something for no reason. That's pretty bad once you come back home. So of course, you said it all, Marketa.
I'm gonna push this situation that you kind of just told us a bit further, Hugo. So you are on site, you are a whole day of flying, right? Really, like, let's say it's a big site. It's been a difficult project. So whole day of flying, you come home, you're ready to upload, and then you see this. What is your first reaction?
I would basically say that this is the definition of a nightmare. From Henry's point of view, I mean, as I told, from a business point of view, you just lost money by doing this. And from a personal point of view, of course, from an organizational point of view, of course. And this is only because of the flight preparation. Maybe it has been done pretty quick, so you didn't figure out that the camera was not well set, or maybe because you didn't took the 5 minutes to check the photos after the flight. So yeah, this should be avoided pretty efficiently. If you do the checklist, follow it, and we'll talk about that, of course, later. But yeah, this is basically the definition of a nightmare that could be avoided.
Yeah, definitely. And then from our experience, we've noticed that it's very easy to fix, and usually it's something that happens on the first time. But once the pilot has been brought into attention that, hey, look, your images are very blurry. Can you check them next time? Usually we don't see these problems arise anymore. Now, of course, I'm usually talking about the customer side, but of course, operationally, Marketa has the edge on things. So, but I think, are there any situations where you, for example, have this problem continuing more and more than one time?
No, I think that, as you said, it's a very, the type that it's not the recurring issue. And that's something that we actually see it only at the beginning when we have a new pilots, new customers, that it can really happen with the first operations. But as we said, easily to fix, whereof the missing data, it's something that it has to be looked more in detail. But here, as soon as spotted, like you said, the best it's always after every flight to check the data offline. Really pick up few random images from the SD card, check the image quality, and then of course this is easy to spot and easy to fix while being on site, and not to spot it few days of course later. But it is all about having the right focus, seeing if it's some manual settings or automated settings, motion blur or out of focus blur. There is several types, but it's always about having the good experience. And once the pilot is really getting up to speed, this is not something that we would expect to have it on the second or third operation.
Definitely. And we've been now talking fully about internal problems, right? So it can be about the hardware, about SD card speed, or just there's a lot of internal things. But how about, like, there's always, external factors. And I think the first one that really comes to mind for me is of course the environmental factors, right? So we talk about weather, having the right irradiance, etc. And I'm going to pass the ball to you first, Yoni, because you're in Israel, and of course for me that I'm sitting in Belgium, well, today we have really nice weather, but that's like one time out of a million here in Belgium, since mostly it's raining apparently. So what kind of problems do you have with the weather, or do you have any, since we think of that you have really good weather over there in Israel?
Yeah, well, Israel is considered like a sunny country, and I think we have, I don't know, between 30 to 40 days of rain in a full year, in average, I think. So it's quite sunny country, let's say. But when it comes to thermal inspections with the drones, we always check the forecast several days in advance towards the mission, and we always make sure that in the day of the operation, we have good conditions to make the operation itself. And for instance, even in the summer, we could encounter days with maybe full coverage of clouds or partial cover of clouds on top of the site. And then the pilot need to adjust. In some cases, when you check the forecast, maybe it was wrong, and you wake up at the same day of the mission and you see, oh, there are clouds. then I think the best way is to abort the mission and not go there, because it's very important for us to make the inspection with the right irradiance conditions. I mean, above 600 watts per square meter, which is the IEC standard. And if we do not have these conditions, then it's better not to fly. And there are some, coincidence when you start, the pilot is coming to the site, starting to fly, and then there's a cloud coming in. So usually the instruction is when we have shade on the system itself, land, wait for the cloud to go pass by, wait a few minutes for the modules to start producing again and heat up, and then resume the flight from the point where you stop. But this is how we usually mitigate. I think in France or in Europe, it's much more challenging than this.
Yeah, definitely, Yoni. It's a totally different story here because we have maybe much more like, I would say 100 days of rain in France, for example. But anyway, we are facing exactly the same challenges. And I wanted to just bring out something. You can maybe from a drone operating point of view, you can maybe say, oh, weather issues are not that bad, it's not that important if a cloud pass by. But the fact is that it has a really huge impact on the data quality, and you find it out in the next slide. But I wanted to point that this is almost the only parameter that you need to be really aware of. So from our side in Europe, I think flying in summer mostly could be a really efficient way to have consistent data, and also flying between 10 to 5 p.m., 10 a.m. to 5 p.m. could be a great way for you to be super efficient in your inspection job. This is the advice that we have been experiencing over the years now.
Yeah, well, I definitely agree, and that's something that you mentioned now that I found interesting, which is the time frame, right? But for example, I'm going to now take an example of things that we see, and from my side, I see it more and more since I mean, we're working in the solar industry, we're working with lower margins, and sites have to be producing as much power as possible in as little space as possible, right? And then we start seeing something similar here as to the left of in this picture, that there's happening self-shading. And Marketa, could you please tell me, for example, tell us all actually on why this is happening? Because it has to have something to do with the time of the day, right?
Yeah, absolutely. So this is the first really great example on showing that when the inspection is flown in the winter. First off, winter is perfect time also to fly the inspection as the summer, but it doesn't have that long day. So we are limited to some time window in a day. So in a winter, of course, the time can be something around noon. We might get maximum of 1 hour of good irradiance. And here we can see that the sun has been really too low. And that has caused this self-shading of the panels. So first of all, we always want to make aware the pilot that when we're going to such a site in the winter, it's really about the timing. It's not that we have a whole day, we can wait. No, as soon as we see the sun and it's a perfect sunny day, which is of course the first condition, then really pick up the best time, which is the noon, and to fly it. Otherwise we will end up with such a result. And it's a pity. It's just about, to delay the operation, but at the end, we will well communicate to the customer and make them, of course, inform that we will just fly it as soon as possible under better conditions to avoid such issues for the next time. Because we can see on the right picture that exactly what Yoni, you have mentioned, we can see the reflections of the clouds on the thin films panels. And that's exactly something that if we see the cloud, later or sooner we will find out too. So if the pilot doesn't wait for the cloud to pass by, we will end up with having such a impact on the analysis afterwards.
Mm-hmm. Yeah, if I can add maybe to the right picture for the audience who might not be coming from the PV industry directly, or either the pilots or they're not, O&Ms. Mm-hmm. What you see on that picture is that some of the modules are very bright yellow and some of them are more dark. That means that the more bright and yellow modules are partially shaded, probably by the clouds. That means that they're producing less and sort of becoming a consumer. And this is why they're more hot than the producing modules, which you can see on the, let's say, right bottom side of the long table. And that obviously causes the analysis to be inaccurate because the platform will analyze these strings as string issues, which probably there is no issue. And we would like to eliminate detecting false anomalies as a result of the environmental conditions.
And I'm gonna, sorry, go ahead.
I just would like to add one last thing about that, because as Yoni said, some of the audience is not part of the PV industry, and this, such as we are at Instagram, and being aware of the impact of the weather and also the time frame and all that could be interesting when you are flying with an external pilot network, because when it comes to flying with your own pilot, when you are an O&M or something like that, of course, this will be obvious for them that the impact of self-shading in the data analysis will be just huge. But from our side, when you are not experienced and you don't know about anything in this industry, just having this kind of picture at the screen could be really interesting to just show the potential impact.
No, it's a very good point. And that actually, I had a question that was really coming along already in the previous slides, but it's sometimes delays happen, right? You cannot say that, okay, we're going to fly every day when you say that you're going to fly, you know, but of course the customers on their side, they care about the return of investment. They want efficient results. They want them fast. How do you go through telling, for example, a client that, look, we cannot fly today, or these results are going to be delayed? Because of course, if I was a client and I'll be paying for these inspections, I'd want the results as fast as possible. So I'm going to start with you, Hugo, since you were the last one talking. So
yeah. Basically, it all comes to having a discussion, a constant discussion with your customer, and also educating him, because Yoni just said it previously. It's becoming, the drone inspection is becoming a standard, but for part of the audience and part of the O&M and the people in this industry, this is a new way of getting data, acquiring data. So learning the people, what are the challenges that we need to face, that we are facing and all that, and just giving information about why we couldn't fly this mission and all that can just, I mean, solve, let's say, 90% of the problems that, and I mean, this, most of the client will understand. And if not, just give them examples, concrete example about what could be the impact. You paid for a service, do you want to get bad data? I think, of course, this way they will understand.
I think aligning the expectations with the clients is really crucial, and you know, it's part of the discussion when you're giving service. Any company who's given service, aligning expectations with the clients is let's say the first step. And in general perspective, I think that when doing thermal inspections, not only that the environmental conditions needs to meet, also the site condition needs to meet, meaning that if there is a failure, the inverter not working or springs are disconnected and they know it in advance, maybe it's better also for them to delay the inspection, because we need their site 100% performing. And in most cases, we also recommend the asset owners or the O&Ms clean the site before we do the inspection, because the platform can detect anomalies as a result of soiling, dropping. I don't know, sometimes I saw automatic robot machines are stuck on the modules, or hoses, or I don't know, some dirt on the modules. Clean the site. We want to detect the internal anomalies in the modules, so that can help you, you know, solve issues with the modules themselves. And in a wider perspective, this thermal inspection that we're doing is sort of like a health check that you go to the doctor, or you take your car once a year to test it. And, you know, the conditions needs to meet for that, and there's no rush to do it. So it's better to wait for the good conditions when environmentally ready and also the site is ready, than rushing and then analyzing and, you know, giving false results. We don't want that.
No, 100%. I 100% agree. It's of course always difficult, because they have these expectations, but indeed, maybe aligning is the right way. But you actually brought me perfectly to my next topic, since you mentioned things that might be blocking the panels. So of course, the other other difficulty when it comes to drone inspections is of course power lines. Now, power lines are the hot topic, since they really can be quite problematic, especially if your drone happens to fly into the power lines and the town next in the next kilometer doesn't have electricity, then we have big problems. So Marketa, on the operational side, how do we mitigate these liabilities and these dangers of like I said, accidentally ramming down a electric power line, and then that's a big money problem, let's say.
Yeah, absolutely. We are actually having really things in place, meaning documentation. So I know that from the customers from the past, if there is such a power line grid over the solar side, we are normally, as a standard way, doing also a risk assessment that we are submitting ahead prior to the flight. And that comes also to the qualified pilot network that we are having. So we are submitting not only the pilot license, the drone registration, but also the liability insurance. So there is a specific threshold that we need to meet, or the pilot needs to meet. And that all comes in a really package that we want to really assure the customer that everything is under control. We have the solution. We know how to fly it. We are having several things, how to adapt the flight height, for instance, the good drone to choose for that. We know that the new Matrix 300 is really having good magnetic interference function, so we can fly a little bit near the power lines. But having all documents in place, that's really the guarantee that we want to bring to the customer, telling them that we have everything in place, and also that the safety first, that's the first thing we want to say. We will guarantee you that we will fly safely, that it's not something that we will put in danger your side or people surrounded also on the side. We want to really make sure that everything is in place. We have the solution in order to make the mission successful.
And that's pretty interesting that you just bring this subject, Eric, because my pilot just called me minutes before the webinar, just telling me that, there's a power line over my side. And that was quite funny, because I knew that we were discussing the subject. And the solution he gave me, and I found that pretty interesting, is splitting the flight into three spare blocks, one on the left side, on the east side, for example, on the west side, and then just a path right over. Sorry, the power line could be a great way also to mitigate and to fly safely. I think you can all agree on that, because this is, the best way not to shut down the power of the nearby city.
Absolutely. I can maybe add that this is really great solution, having separate block only fly the power lines a little bit higher, to always keep 20-30 meters maximum above the power lines, to really keep the drone safe. And the message is also that this won't actually impact the analysis. We will always guarantee that we will, have always the same results. This is just a precaution that we're gonna take to have a safety flight in the first place.
Yoni, do you have any experience with flying over power lines in Israel, or is it not that as big as a problem?
Yeah, I must say that usually we don't see power lines over the solar site itself, because obviously it causes constant shading for modules, and the asset owners wouldn't like that. But we can occasionally see power lines cutting through a site, and then the site is splitting into two. And like everyone mentioned here, the tactic, to mitigate with that is either splitting blocks east, west side, or northwest according to the power line, or using a drone that can fly all over it. I think with the Matrix 300 H20T, you can fly 50 meters with the correct GSD that needed and the overlap. And I don't think that the power line would be 50 meters high. And so you can keep safe distance and do a consistent flight, no problem.
Speaking of consistent flight, of course, power line is just one object that is, let's say, on a higher ground level. But when we're talking about like very challenging terrain, so Yes, I see. Yoni is already laughing when he sees this. But so this is indeed, I think this is a site in Japan, or I think somewhere around in Asia, and I mean in the Pacific. So how do we mitigate this? Because this terrain is very difficult to fly over, because for the drone to know exactly at what height, suddenly up and down and up and down. What kind of tricks do you guys have to work with this type of terrain?
I really hope that you were gonna bring this subject here, because I mean, this is really, really important for the drone to always keep the same distance between the ground and the drone. So having the same GSD for all of the site, this is really the key here in the solar industry inspection. And maybe you can do it in a manual way. This is of course the things that I think Yoni is doing at the moment, and I think this works pretty efficiently. But we found a solution to make it automatic, and you might know that this is something called DSM, or digital surface model, that you can put into the drone software in order for the drone to automatically calculate the variation of the altitude, and also to adapt its altitude while during and performing the flights. So you can find it for free in most of the country, most of the European country. For instance, France, it's absolutely free. You can find it at the IGN, the Institut Géographique National. And you can also, even if the site is pretty far away, or in a desert country or something like that, you can do a topographic survey first, and then import the DSM extracted from this topographic survey into the DJI app or any app that you are using. So this is a way that we found out to do so, because of course, while you see this kind of picture, it could be like, oh my god, oh am I gonna do this?
Yeah. And we actually use a more primitive way up until now, but I think with the tips of Hugo, maybe my pilots also can improve. But actually, when we have this hilly terrain sites, then usually we ask Marketa or Ryan or somebody from Sitemark support, we open a mission, can you please help us splitting the blocks? And then you split us the blocks according to the terrain. So the pilot needs to fly separated blocks, maybe 4, 5, 6 blocks for the mission. But then every block has the same GSD, and you can analyze it, and it's not a big issue. A more primitive way than using the digital surface model, but it works as well.
Mm-hmm. And Marketa, I know that from operational side, we actually also split sites into blocks for other reasons as well. So usually on larger sites, for example, even if they are flat. So could you tell us a bit more about why we think that splitting in blocks is important?
Sure. We have also a great example here, as you can see on the next slide. We are splitting the blocks not only for the height difference, as you could see in a below image. This is something that we are fetching from the Google Earth. This is not such a great difference on the side, but it shows nicely it's a 30 meters deviation that we should cut. As you said, we are cutting as well due to the size of the site. So if we would have a site big, 200, 300 hectares, 500 hectares, this is something that we would split it in a smaller blocks. And also to be more efficient, we want pilots that if they are flying such a big site, we will not wait for them to finish in 2 weeks, 1 week, and to get all data in. We want it to be efficient and to start delivering the data as soon as possible. So in this case, we will be flying in a little chunks, little blocks. And end of the day, the pilot can always upload the data, check the data, send it to us, and we can really start processing such a big site. That's why we have a success in having big sites on the platform, because we can handle them in this way as well. And this is really an operational matter for the big site with the blocks, but also on the other hand, it helps the pilot because of the maximum waypoints that they can have in the flight application is the same matter. So it's just 2 in 1 in being efficient on both sides.
Just giving a quick feedback on this one. Having also the site splitted in separate blocks also make it easier if you have to refly it, because you know exactly the block that have been evolving issues, something like that. So this is also an efficient way to refly this.
Yeah. And then now that we're talking about elevation, so there's one, let's say, segment that of course gave us a bit of a headache, to be honest, at one point, but I think we came up with a quite a good solution. Especially, I think this is very applicable to you, Yoni. So you fly a lot of rooftops. So rooftop installations, they can be very difficult to fly, but I think you came up with a solution for rooftops together with Marketa and the rest of our operational team. I'm going to give a shout out, of course, to Omer, Ryan, and Marketa, of course, for the great operational supports in these kinds of questions, or any questions that our pilots have. But could you tell us a bit about the solution you came up with rooftop installations?
Yeah, so recently in the past year, I think we did quite a lot of small commercial rooftops. I think it's a very interesting segment in the market. There are a lot of rooftops in Israel and obviously in Europe as well that haven't been inspected for several years. And when we started doing this, we found out a lot of anomalies, which asset owners didn't even know that they have it. But then we had sort of a technical challenge to meet, and that's how to adjust the flight to the height of the building. So the solution that was developed together actually with your guys is the pilot is planning the mission on the ground level, and then he measures the height of the building. He can measure it, by looking in Google or something like that. By his eye, he can guess, or use some kind of a laser device to measure the height of the building, and then he add this to the flight parameter settings. And in order to adjust to the same GSD, he just plays with the overlap, increases the overlap front and side in order to meet the same time of flight when he was planning it on the ground level. And this assures that it will be the same GSD and a full coverage of the rooftop, on the rooftop level. But I think, Hugo, you have a more advanced way than this.
No, we've been doing it. This is a pretty efficient way to do so, because when we were flying with the M210 and something like that, we didn't have any other solution to do so. But now that we are flying with the Matrix 300 and also the Mavic 2 Pro or something like that, we can just add the value, which is the height of the building, into the surface to takeoff altitude, and then the application is automatically calculating the new GSD and the new overlap in order not for you to tweak with all the settings and all that. This is automatically done by the application once you just fill up this blank field, because at the beginning it's just blank, and then you just put, let's say the building is 10 meters, you put 10 meters in this field, and it automatically calculates the right GSD.
It's called surface takeoff?
Surface to takeoff altitude or something like that.
Okay.
Are you translating it directly from French, or?
Yeah.
I did my best, but you'll find out. This is in the flight parameters. Okay,
great. That's really good to know. And Marketa, just out of curiosity, is there any other aspects that should be taken into account except for the overlap, of course, and the height when doing doing inspections on rooftops?
Yeah, I think that the third parameter or aspect we can mention is the minimum amount of images, because it's always something that I feel it can be a little bit underestimated, when flown, because it looks, okay, I have one building, few panels on it, right? I need to take few pictures and go home. That can really happen. And I saw so many data sets like that. It's actually really better stay a little bit longer and cover, let's say, minimum of 20 images, having 4 flight lines, a little bit something that it's above the building, and ideally, of course, few flight lines that are also outside. And that will really guarantee a sufficient overlap for the images and having good data when they are being uploaded, because sometimes things that, that site seems small, pilots tend to just have a few images and leave the site, and we really know that. So it's really better to have a 5 minutes longer flight with the great images a little bit beyond, but also this is something that, of course, if it's a building, we know that there are restrictions also. If it's a really in a congested area, it can be in a city. Flying a little bit outside of the boundaries can be also another issue, because if the panels are just ending at the edges, you know, that extra flight line can be just above the street. So there are different aspects to take into account. But with a good drone, with a good, actually the VLOS, the visual line of sight, let's keep the safety first again and deliver indeed good coverage at the end of the day.
And indeed, talking about safety first, of course, and then you mentioned flying in cities.
I just wanted to add 2 remarks about that, because you just said it. You just said it, Marketa. Once we are flying over a rooftop, it might be, and of course, most of the sites are in congested area or in industrial area or something like that. So if you want to fly this kind of sites, just be aware about the people around this kind of buildings and something like that, because this is really something to take into account while you are flying those kind of situations. And it can also have a huge impact on the process, on the preparation process that you need to figure out. Maybe if you're flying structures about parking lots in a commercial area or something like that, of course, fly it on the Sunday. It will be much easier not to have people running around and passing just beside your drone or something like that.
No, indeed, and that's the whole idea of course, we have this sometimes that you need to actually start to look for permissions to fly, for example, when it's controlled zones. And that kind of leads me to of course, the next point, which is the flight preparation. How do you prepare for flying? And I think this is something that when you're a pilot, you might see quite a lot, depending, of course, where you're located. But Hugo, I think you recognize where this image is located, where this image is coming from. So I mean,
pretty congested area here. This might be Paris or something like that.
I think it's, yeah, I think it's somewhere in the Paris, either it's Paris or next to Paris, but indeed it's a very difficult zone to fly. So imagine that you have to do an operation. So how does the process look like for you when you're applying for a flight in a controlled zone?
Basically, there's 2 kinds of controlled zone that you need to be aware of: civil aviation zones and also military bases. But having this in your mind and checking it during the flight preparation and knowing that you can almost fly anywhere. Let me give a quick explanation here. If you take your time to do so, you might get all the authorization to do so. Quick anecdote, we fly just, let's say, 100 meters next to a military base last summer. So just telling you that if you take the time, and also if you advise your clients about the need to get the authorization, of course, you can almost do all the jobs anywhere. But I'm speaking only about France, and I know that in other countries, sometimes it's much harder to get the authorization, of course. But having this in mind, just take it into account while you are planning your inspection, and it should be all right.
I agree. I think also in Israel, you can fly almost anywhere. Of course, you need to follow the authorities' regulations, but if you prepare in advance, you can fly either beside the borders or near airports or military bases. And usually my pilots are certified, so they know who to contact with and to get the permissions in advance. So it's a challenge, but certainly possible to mitigate.
Yeah, I'm going to, for example, from my own experience, I had a customer who, unfortunately, and Marketa, you were also involved in Spain, and there were, I think it was two smaller sites that we unfortunately couldn't fly because the pilot tried and tried and tried. We tried to help him as well, but we couldn't get the permits to fly. So sometimes, indeed, we talked about communication before, and to be honest, if you say like, look, the reality is this: we are next to a military zone or a no-fly zone, we cannot do it, then I've never had a problem with clients not understanding that. Of course, they're not gonna expect you to go against the military and say, no, we're gonna fly. No, they usually take it very in a very understanding way. So of course, again, I think communication is key, and then we're just talking about preparation. So it was interesting, Hugo, you sent this to me, and you mentioned that you have some ex-military guys in your team, and of course We have, of course, some ex-military guys also in our team, and they all think the same. Having a good checklist, having a good preparation list is absolutely key, because if you have this good preparation, the job is already half done, right? So can you, so what kind of, what is important for you in a checklist?
What is important is just to personify it first, because you can find any kind of checklist, even on Sitemark website, you can find some resources about that. But having a personalized checklist which is designed to match your experience and to rely on the experience of your colleagues is just the key here. We have a checklist in order to prepare the hardware and in order to prepare the mission first. On the field, but is dedicated checklist on the field, and also for the after flight, because when it comes to different parameters, when it comes to so many variables, you can just forget about something. Once it's your 10th inspection of the day, of course, you can be a bit tired or something like that, and you can forget something. So just keep the checklist in mind, follow it, even if you are doing it for the 100th time, no matter what, just follow it. And I think, yeah, you can all rely on the fact that we are ex-military, or most ex-military. And I think this is a way to work that is pretty efficient.
Mm-hmm. I think Yoni, you as well, you probably have a type of checklist. It might not be the same, of course. You have different kinds of situations, but tell me about
Yeah, me personally, because I'm not the pilot myself, I don't have the checklist. But let's say that training the pilots and qualifying them, they all have their own checklist. And like Hugo mentioned, if they lack understanding of something, then in Sitemark website, they can find the resources. I think Marketa is writing an article about this, or any other member in Sitemark is having articles about what to prepare, how to prepare. And from there, you can, take a checklist for your own.
Yeah, the operations team is getting a lot of shout outs today, so enjoy it, guys. So here as well, this is of course before the flight, but I think Yoni, this definitely looks very familiar to you, is of course the photo checker. So yeah. What is the photo checker? How do your pilots use it, for example?
So the photo checker is a tool, is an app in the pilot app, actually, in the platform, that allows the pilot to check his coverage of photos in the field itself. Usually we recommend to our pilots to use the photo check once they finish the block or finish the flight, just before they leave, because usually I send my pilots out there into the middle of the desert, and they can drive hours to the site, drive hours back home, and they don't want to go home and then find out that they missed a flight line, or I don't know, missed some photos, and then they will need to drive back. And that happened. Marketa sent us back several times. And if this is what we need to do, then we do it. But I think the platform allows our pilots to check themselves before they go back home, and before uploading the data. I think Marketa, it's not actually uploading, it's just checking, right?
Yeah, I would like to add, it's not really something that, and especially when you said it's in the middle of the desert, we can see the challenges. I'm absolutely seeing that there is no internet connection, anything. So in this case, the photo checker works on really having a light internet. It can be something as a hotspot from the phone, just having a 4G, because the data here are not really uploaded. They are kind of like projected on the map. The system takes only the metadata, the EXIF data of every image, and it projects the location on the map. So the dots you see, it's location of every photo, and that you can see the full coverage. The colors there, it's a kind of like a timeline of the picture that the flight has taken place. So really this is something that it's few minutes if it's a small site. That's why also this is very efficient. And coming back to the blocks, if you have several blocks on a big site, this is really something coming to efficiency as well, because imagine having really thousands of images and checking them at the same time. This won't really work. Talking about efficiency, but in the small blocks, you can really do the photo checker after every block flown, while really having just a light connection with the internet from the phone. That's enough. So we really recommend using this when really leaving the site, to make sure that all data have been covered. That's really the
Otherwise,
recommendation.
otherwise you're going to get a text from Marketa at 12 at night. The photos are wrong.
It
And
can
nobody
be
wants to
nice,
have
yeah.
that, right? We're
Very.
almost at the end of the little coffee talk that we have, but I think it's very nice. Marketa and the rest of the team, of course, we all put it together. It's a little, I think it's 10 things to keep in mind when flying, of things that inspection mistakes that can go wrong. So of course, Marketa, if you have any comments on the different aspects.
Absolutely. We would like to really wrap up this nice and pleasant webinar that we would like to just highlight few things that we really see that are happening and that are keep happening. So for instance, having the camera in a right angle in the nadir, changing the zoom levels. This we can see with the H20T camera that the zoom levels were changing. So really that should be one aspect to keep in mind. Weather we have discussed, really the best aim for the best weather possible, meaning blue sky. Low overlap we have discussed. Another point, if we have a missing data, meaning the only thing that it's the low overlap which will impact the whole data analysis, blurry images. And then also really the timing. I can see this also very happening, not to fly too early, not too late, pick up the right time, the right weather, and then you are halfway to have a successful mission.
Great.
I wanna just maybe summarize something, and I assume that our audience is diverse between maybe asset owners, O&Ms, and pilots themselves. And just saying that nowadays with the equipment and the drones of DJI, it seems like everybody can, just learn and fly. And in some aspects, this is right because it's more accessible and more people can, learn and fly themselves. And this is a good thing. But also keep in mind, if you want to fly on your own, then you have to be certified, you have to be qualified, and you have to follow, the checklist and our tips, and I think, and other more resources to learn how to do it correct. If you don't have the resource or the time to learn and to be a professional in this, maybe it's better that you leave it to the professional pilots like Hugo or like the pilots that I'm using, which are doing this not only for the thermal inspection, they're flying, on a daily basis. So it can be done, self-flying for O&Ms and asset owners, but, take the time, think about this. And if you want, to have a quality data and a quality analysis, just follow the workflow, and then you'll get a good result.
Thank you. No, indeed. In the end, experience, you can learn it, but of course it does require a commitment. And speaking of commitment and time, so I want to thank, first of all, I want to thank all of you for joining this little coffee talk that we have had. It's of course, Marketa, I see you quite a lot since we work in the same office, but Hugo and Yoni, it's great to see you guys again, virtually, unfortunately. And of course, I want to thank, everybody who joined us today in this webinar. Of course, like I mentioned, the recording will be shared later during the week or the next week. But of course, we have some questions, and we have a bit. Let's see quickly. We have about 6 minutes, so we can take some questions. If your question doesn't get answered, do not worry. We're going to answer it directly via mail, since you have left your email information. But just to start with the first question, and I think I'm going to point this towards you, Yoni, since you are the one who uses a lot our platform. So what anomaly types can be spotted on the platform through with this quality data?
Oh, this is a question for a whole new webinar, I would say. So I will say just briefly that the platform can detect almost all type of anomalies that can be detected on solar modules, from hotspots to diodes to string issues, or single diodes, double diodes, whatever, PID actually, which is very important to detect if you have a concern of this kind of phenomena on your modules. And also it can tell you the causes, meaning if it's an external thing that caused the anomaly, like soiling, or it's an internal thing that then you need to, I don't know, maybe send a technician to check the modules. But in overall speaking, the platform is covering a lot of the, I think 100% of the anomalies that can be found from inspecting above, of course, not underneath. We cannot detect, I don't know, cables issues, but everything that can be detected from above on the modules, almost 100%.
Okay, great. Thank you. There's another question that is going to be aimed at you, Hugo, since you're the pilot that actually goes on the site. So the IEC standard does not mention anything about the ambient and module temperatures. So based on your experience, what is the optimal ambient and module temperatures for conducting thermal inspections?
Basically, I'll divide my answer in two parts. The first part is always have some kind of measuring device in order for you to know if you're matching the IEC standard in our irradiance. This is a device that can be found, let's say, for $100 or something like that. So first of all, have it with you while doing this kind of projects could be interesting. And also, if you don't have this kind of device, just, I think, flying with clear bright sky, and also from, let's say, 15 degrees, 20 degrees could be a great way for you to, let's say, be sure that the weather conditions are okay and you will have not to go on the field once again because the data are bad.
Okay. So there's a question that I'm seeing that has come quite a lot, and I think it's going to be for you, Marketa, and of course you guys can also feel free to chime in. But Marketa actually wrote a very great blog about it. But which drone would you recommend?
Good one. So we can see lately, of course, there are really lots of drones out there. There is a big range on what we can recommend, but lately we have, of course, two favorite ones that DJI has released. So we can talk about the drone Matrix 300 together with H20T camera. That's a very great combination on how to do very good solar inspection. Hugo is using it. He's a great user of it. And the difference there is also because with this camera, with this drone, specifically with the drone, you can really use it for different applications. So it's not only for the solar, but it's based on the business case. If the customer is really, having a large scale projects and sites, maybe there will be also a solar construction. He wants to first scan it with a high resolution sensor and the RTK, of course, function. And then to move to thermal inspection, this is the right combination, we would say, and among others application. Whereof DJI has released also this very small compatible drone, Mavic 2 Enterprise Advanced, which Yoni is using for his solar site with his pilots. And that came, of course, into very big surprise because this drone is really delivering almost same data as the H20T, but it is limited to, let's say, some industries like the solar, right? So it has really good results for solar, but it's not something that we can use it for different applications. So there is this limitation. But if we talk about small sites, rooftops, ideal, business case, that's something that we would recommend, of course, to buy this drone, buy several, if you have a big portfolio, several pilots, and just use it. And the only thing what we can, of course, recommend is indeed, if you would like to have if you have some doubts and you want to check into more details, to check our website for the blog, which will give you really good insights on how to choose the right one.
Yeah. And indeed, this blog is going to get also shared after with the webinar recording. So that's not a problem.
Just answering Krish Marshall in the chat, yeah, the Mavic 2 Pro Advance is quite hard to get these days, but I think the Mavic 3 is a pretty nice aircraft, and I think a thermal version is coming lately. So just stay tuned.
You have a sneak peek here.
Sneak peek. And there's one more question, and then unfortunately we're going to have to close because the clock is ticking, and we all have, of course, busy days still ahead. So the last question that I have here that I have the time to answer is, how accurate is the AI, and does it ever make any mistakes? And since you guys already got your moment of fame with the answers, I'm going to take this one. So of course, the AI will never be 100% accurate. I think we are somewhere around 95% or more or less. But this is why we at Sitemark, we always use humans in the loop. So humans in the loop is our way of having certified thermographers in the team that actually double check data to make sure that we actually offer that quality data that we've been talking about during the whole webinar. Since otherwise, if we make mistakes even in the analysis, then of course the quality data doesn't matter at all if we're making the analytic mistakes. So thank you very much for everybody for joining us. Stay tuned during this week for the webinar recording and the mail with the blog included if you're interested. And if you have any questions, do not hesitate to reach out to us. You can see our emails here and our beautiful faces. And of course, for those that didn't get their questions answered, we will answer them privately via mail. So thank you very much. And I wish you all a very good day. And thanks for joining the webinar,
Thank you very much, guys.
Thank you.
Bye, guys.
Bye.
Bye.
Bye, all.